Hi, Mr. Robert, owner of Tacos El Robert. Thank you for trusting us to build your high-tech tortilla catapult. The purpose of this tortilla catapult project is to be able to accurately launch a tortilla in a repeatable, efficient way. Through this project, we expect to be able to determine how increasing the force applied to the moment arm of the catapult affects the trajectory of the tortilla as well as its projectile distance. The course topics that will be covered in this experiment include measurement methods and standards, error propagation, uncertainty analysis and confidence intervals, calibration, and force measurements.
The test will be conducted inside a gym in the Hyper building, which we're at. Then, the court will be cleared of all obstacles, and the launch zone will have measurement marks to track the distances. Come on! Cleared of all obstacles, we have our launcher and the weight to hold it down. Protective equipment will be used to ensure the safety of each scientist. Closed-toed shoes will always be worn, and no one will stand either directly in front or directly behind the launcher during the test. And during the test and before the test, the launcher will be inspected to ensure that it's safe and there are no issues.
There's three main parts for the launcher setup. First is the 45-pound dumbbell weights that are placed at the front and at the back if needed, which will allow to secure the launcher to the ground. Second, we have the force mechanism, which consists of elastic bands and will later be replaced with a spring with a known spring constant. The final is the tortilla holder, which at the moment is secured at the end of the moment arm, but in future runs we'll have additional slots all the way down the moment arm so that we can adjust it for varying results.
So the big question is, what variables are we measuring? First off, obviously you got the moment arm, which is going to be adjustable. You have the length of the unstretched spring and the length of the stretched spring. We have the distance traveled by the tortilla, which should be better secured. We have the weight of the tortilla and the diameter that we're going to be measuring. In addition, we have a few sources of error. We have precision errors and bias errors. Precision errors are going to come from the length of distance traveled in the measurement of that. It's going to be plus or minus about a 1/16 of an inch due to a tape measure. We're going to have a precision error in the measurement of the length of the moment arm due to the same tape measure. The precision error in the mass of the tortilla will be plus or minus 1/100 of a gram based off the scale we're using. The precision error of the thickness of the tortilla and the diameter of the tortilla will be roughly 1/1000 of an inch because we'll be using calipers. Bias error, the biggest bias error is going to come from the fact that we're neglecting air resistance in our calculations. So I was expecting it to go all the way across the room, and it didn't, probably because of air resistance. So we're roughly expecting about a 45% error from that. In addition, we're going to have a bias error from the length of the stretched spring, which will be the same every time, which will create a bias error. We're also going to have a bias error if we assume the given K value is accurate of the spring that we order, and we're also going to have a bias error if we assume the sample size of the mass is accurate.
All right, so Cole just walked us through some of the error we're expecting. Here's how we're going to mitigate it and get the best results. Number one, we're inside. We've got no wind kind of skewing our flight path. We also have a fixed catapult position. It's not going to be moving around. As well as we're going to cut a little notch into the front so we can measure from the same spot every time. Next, with the tortillas, we're going to measure the thicknesses of 32 tortillas so we can use some nice population statistics and get some averages. For the diameters, we're going to take 3 diameters because they're not perfectly circular on 8 tortillas for a total of 24 measurements that we can use a little bit of students' T distribution on.
So what we're going to do, we're going to launch as many tortillas as we have. We got this pizza box directly in front of me, and we're going to see how many of them we can get to land on it. 0. Ho ho. Ho ho. Oh, that one hit the box. That one hit the box. We'll count it. So there's some room for improvement. Chase, what did you bring us?
Your salvation.